So let's talk about the next variation in part 3. This is a continuation video and we are talking about the type 3 problems for variance, standard deviation and CV, coefficient of variation. And I've already covered 2 episodes prior to that. Please check out that before you watch this episode. And in this episode, we are going to talk about one of those variations within this type 3, and which will be to find the consistency using the coefficient of variation. So whenever they ask you to find consistency, it's implied that you need to find the CV. And if you're not familiar with what is a CV, please check out one of my episodes. I think it was episode 10, where I have detailed what is a CV and given a context of why it is important and how should we calculate. A very simple calculation. And you for sure will get one question in exam for 3 marks on this one. And the interesting thing is, like I said in my previous episodes, for the last 4 papers, this one specific problem with these exact values where they are given you 2 sets and these values are there. This exact problem has been repeated 3 or 4 times with no change. See, over here it's repeated, over here it's repeated, over here it's repeated, and they have skipped for summer 2018. The question still appears but for different values. But again, it comes back on 2017 in the second part for 3 marks. You can ignore this part, but over here again for 3 marks, the same set of values. So it looks like there's a pattern where this question definitely comes, and for the most of it, it will come with the same set of values. So you might as well memorize the answer and just write it and secure your 3 marks. So let's talk about solving these problems, which are based on finding the consistency. If you see here, there'll be values given and you need to find which of the 2 set is more consistent. Okay. So as a global thumb rule, whenever they talk about finding the consistency, they are talking about nothing but calculating the coefficient of variation, or which is CV. And as a rule, we have seen that CV is nothing but an inverse measure. And what does it mean? The lower the value of CV, the better the consistency. So it's an inverse measure. So that's it. The smaller the value of CV, the higher the consistency. So you have to find the smaller values, and whatever is a smaller value, that becomes more consistent and hence the answer. So keep that in mind. Okay. So let's solve because I just need to solve one problem because it's repeated all along the way. So let's take the most repeated problem, which is in 2019, both the sides, 2018 and 2017, this particular set of observations. And we know it's an inverse measure. The first thing is write the formula for the variation, the CV, which is, and the way to remember is CV is nothing but the ratio of standard deviation over mean multiplied by 100, and it's expressed in percentage. And I've told that several times. So this is a formula. In case you don't want to remember this statistical jargonish formula, you remember simple ratio. Variation CV is going to be standard deviation about the mean. Okay. All right. What you do is draw a simple table. Write the problem as it is. Whatever is the problem given, write as it is. Over here, if you see, the x bar is given as mean. Mean is nothing but the x bar, and sigma is nothing but standard deviation. So they've given you x bar and standard deviation for both the sets over here. So I've taken this, this is kind of in this column format, and I've put in the row format. So I've added row 1 for set 1, row 2 for set 2. The mean is given, this is given, and this is given. We have to find this, and this is the calculation for that. Okay. So I've applied this simple formula, the ratio of SD over X. So what is the formula for, what is the CV for the first set? The ratio of SD over this. So SD over mean, that is 7.3 over 82.5. And since I'm going to add a percentage, I'm going to multiply by 100. I get this value of 8.8%. Similarly over here, SD over mean, which is 88.35 over 48.75 multiplied by 100 for the percentage, I get 17.12%. And based on these sets, I can clearly see the CV for set 1 is less than the CV for set 2. The lesser, the more consistent. I know that, and hence set 1 is more consistent. Whatever is in green is your final answer. Easy 3 marks. You cannot go wrong with this. Okay. The one-off problem which I have covered when I was trying to explain the context, because this was a useful problem, is the average run scored. Let's take a cricket match, and let's say there are two players, let's say Rohit Sharma and Virat Kohli, and they're playing 5 one-day matches, the same set of matches they're playing. And these are the scores in terms of mean, which is X bar, and standard deviation, SD or sigma, right? So this is the mean. So we have got the mean and we have got the standard deviation, and we need to find which batsman is more consistent. So again, over here, since they have given you the context of batsman and average, it's easier to understand, and this is what I used to explain the concept of CV. So similarly, I'm drawing a table, I'm putting it in the row format, same A and B, and we have to find the CV green value, because we have to find which player is more consistent. The lower the value for CV for a player, the better the consistency, and the calculation is simple, ratio of SD over mean. So this is the numerator and this is the denominator, numerator and denominator. I'm taken the values, and over here I get the values in terms of percentage. I think I missed it. You put the percentage values. Okay. So the CV value for batsman A is 11.59, and the CV value for batsman B is 11.68. Slight variation, not very much, but as per the rule, the CV of A is less than the CV of B, and hence A is more consistent than B. That's your final answer. And the way you see it is, like I've explained before, typically they are playing 5 one-day matches, right? So we have got 1, 2, 3, 4, 5. So we have got 1, 2, 3, 4, 5 for both the players, right? Like this. And we have not been given the individual scores for each of the matches. For example, the average for A is 44 runs. So it might be, let's say, and we are talking here is A is more consistent, right? So it might be like this. For example, let's say 43, 44, 45, 44, 43, something like that. So the consistency is better because the overall average is 44, and all the numbers is consistent across all the games. It's not varying. Okay, and hence the standard deviation also is less. It's like +5. So at the most for 44 in some matches he would have at the most gone up to 49, because 44 plus standard deviation 5.1 is 49. So at the most he would have gone up to 49. That's the standard deviation. That's how you understand that. So this is like this 49, and the average, let's say it's not going to be the exact average, but let's assume that the average of all this comes to 44. But we can clearly see that it's a consistency. But we have not been given this scores, so we don't know that. That's one of the things that you need to understand when we calculate SD and CV. We need to apply the formula, but we will not know based on the marks where is the consistency. If they are given the individual scores, you can clearly see the pattern and see where is the consistency. And let's say for B, it's still the average is 54. Okay, it's a better average, but the standard deviation is high. So that means, and it's not consistent, so it might be all over the place. So in one match he might be 44, then second match he'll be 59, then he'll be 54, and the standard deviation is +6. So 54 plus 6 is roughly say 60. So you can see, although the average score is better, but the consistency is not very closely related. The score is very deviating from the mean, and it's all over the place. So that's what the contextual meaning is. So since we don't have this, we'll not be able to understand who is a better batsman in terms of consistency. But if you calculate this way in terms of CV and formula, you can still find out. So I just wanted to bring that clarity on why it is used and how it is used, and how it kind of loses the intelligence that is provided by the individual marks, because individual score, because we don't have this. So anyway, easy 3 marks, applying a simple formula and then calculating. If you see in both the examples, the formula is still the same. The previous episode also, this is the same formula. Here also is the same formula, and this will keep on coming. So typically there will be all the 3 variations which I'm going to cover, which I've already covered, the last one, this one in the next episode. You'll see in all the 3 variations, they'll be asking you, all the 3 varieties of the problems, they'll be asking you to calculate CV, and this formula is the easiest one, SD over mean. So always remember that. So I'll see in the concluding episode where we talk about another variety of type 3 problems that comes for 6 marks, and we'll talk about that in detail, where we have to calculate more than one value. We might be calculating SD and mean and CV and so on and so forth. So we'll see you in the part 4 video of that on type 3 for 6 marks.